Hi guys, hope you are all doing good. So today we are going to look at percentage. Okay, this is a very important topic which you need to know to be able to use it across different chapters. Percentage is a stepping stone for many chapters. So let's get into this directly. So what do you mean by percentage? Percentage is something out of 100. Simple, to put it simple, right? Out of 100, right? So if somebody says that I have scored 60% marks in school, right? What do you mean by that? It's simply 60% marks in school. In a particular subject, you might have scored 60%, 70%, 80%. What does that mean? That is nothing but it is 60 out of 100. 60 divided by 100. That's it. So your marks scored is this much. The total marks of your examination was this much. That is what it is. Okay. So if you look at it, whenever there is a percentage symbol associated with a number, right, you can just replace this by divided by 100. That is what is percentage at a very high level. Okay, so that is one thing. Now, second thing is that the second variant of percentage is to do that you scored 60 marks out of 100, right? 60 marks out of 100. For example, if you have scored 60 marks out of 80, then what is the percentage? They can ask you that what is the percentage you scored. So in this particular case, what you need to do is that marks scored 60 divided by 80 into 100, because what you're trying to do is that you are converting that into percentage over here. Now look at it, 24s are 25s are, right? 4 15s are. So if you look at it, when you multiply these two, right, how much do you get? You get 75%. So if somebody asks you that you scored 60 out of 80, what is the percentage of marks scored? You calculate it in this way and show it to them as 75%. So you calculated 75% of the marks. This is the very basic definition of a percentage. Now there might be a lot of problems related to percentage, because this chapter, if I remember correctly, right, gets started from class 5 onwards and it keeps going for different classes. You keep using this one for like till class 10, class 11, class 12, all those. Okay, so now they might ask you to basically convert a percentage into a decimal. How do you do that? Suppose they gave you 40% and they ask you to represent this as a decimal. So how do you do that? As I told you, right? 40, I'm not going to write this percentage. Instead of that percentage, I'm going to write divided by 100. So if you look at it, 1010 gets cancelled out. You have 4 by 10. 4 by 10 is nothing. It is 0.4, right? So we have represented this in a form of a decimal. Similarly, somebody may ask you that can you write 35% as a fraction? Can you do that? Yes. Again, 35. Okay. I'm not going to put this percentage symbol. Instead, I'm going to write 35 by 100. So I have a fraction, but you can see that you can further reduce it. So it is 5 7s are 5 20s are. So your actual answer is 7 by 20. Make sense? Good. Now let's understand this concept through a couple of simple examples, right? For example, if I take a mixture, right? A mixture, right? When I talk about mixture, right? Say it is a liquid mixture, right? So what in a mixture, suppose I add lemon juice, I add water, right? And I add some, say, sugary liquid again, because it's a mixture, right? So I'm just taking it as liquid. Okay, for example, and this mixture is, say, 100, it's 100 1000 milliliter. 1000 milliliter is nothing but it's 1 liter. Remember, okay? And I say that lemon juice, I'm going to put it in the proportion of 10%. Water will be 80%. Water will be 80%, and I'm going to put sugary liquid as 10%. Now, if you look at it, right? in this particular mixture, the total volume of the mixture is 1000 milliliter, but the weightage of each component over here in the mixture differs. Now, if you want to calculate the amount of lemon juice in that 1 liter of mixture, what are you going to do? You are going to do 10% of 1000. Right? That is what you are going to do. In this particular case, water 80% of 1000. Right? And again 10% of sugar, basically 10% of your 1000 again. Okay? So what do you get? 10% of 1000 will give you 100 milliliter. This one will give you 800 milliliter. Right? And this one will give you another 100 milliliter. So when you add all these things, right, look at it, it is 10,000 milliliter. And the percentage of all the components should also add to 100%. Always remember that. Okay? Makes sense? Similarly, if I take another example, right, you go to everybody, all of you go to school, right? In a school, right, you have boys plus girls in the class. Right? Boys plus girls in the class. And the total strength of your class, maybe say, I'll say there are 90 of you. There are 90 students in for example, class 7. Class 7. Well, I'll put a section also. These days sections are very common. Okay? There are 90 students. Now, if somebody says that there are 40%, so 40% girls in the class. 40% girls in the class. So what happens? What are you left with? There are boys, additional boys in the class. What will be the total number of boys in the class over there? What will be the percentage of boys? It will be definitely 100 minus 40, right? Which is equal to 60% boys. Look at it. Because you have 40% girls and 46, so remaining 60% should be boys. Now you have the percentages. Can you calculate the number of people, number of boys and number of girls in the class? Yes, I can do it. It's 40% of 90 and this will be 60% of 90. So 40% of 90, what do you need to do? 40 divided by 100 into 90, right? 10, 10, 10, 10 goes. So you get 36 girls in the class. So 60% of 90, 10, 10, 10 gets cancelled, 54. Look at it. This totals to 90 and this totals to 100%. That's how you need to understand percentage. Okay, this is how you calculate, and it's always that whenever there is a mixture or there is an alloy, there are total number of students, there are total number of people in the country and all those things, everything should add up to 100% when we are talking about percentage. And the total number of people should also add up to. So 100% here, if you look at it, 100% of students is equal to 90 kids in the class, both boys and girls. Okay? Another very important scenario with percentages which we use in real time, right? Mostly in real time throughout our life is to calculate the increase in percentage and calculate the decrease in percentage. So I have just put two examples over here to make you understand very simply how do we do that. Now if you look at it, right, the population in year 1 is 25,000, okay, and the population in year 2 has gone up to 27,500. So what do you see over here? It's a clear increase of population over here. So what do you need to find? If I have to find the percentage increase of that particular population, what do I need to do? I need to first find the increase in population, the number, right? Increase in population will be what? 27,500. Sorry, 27,500 minus 25,500, right? Which gives me 2500. Right? That's the increase in population. Now they have asked us that in year 2, what is the increase percentage? So when you have to calculate the percentage, right? So percentage increase is always going to be calculated like this. What is the increase in population? It is 2500, right? What was the original population which we started with? It is 25,000, right? Into 100, because we are calculating the percentage. We want to get the percentage, so you have to multiply it. So it's the same concept like marks, what you have scored in the exam by the total marks. That is the same concept which we are using, and into 100. So if you look at it, this gets 10, and here, if you look at it, the population increase between year 1 and year 2 is 10%. Make sense, right? Now let's go to the decrease case. Okay, in this particular case, what happens when you buy a car or a bike or any object, right? What happens over the years? The value of that object depreciates. It always depreciates. It doesn't appreciate. Okay, so what happened? So in this particular case, if you look at it, 2 years back when I bought the car, it was 5 lakh rupees or 500,000, right? Now, cost of the car in the current year, later 2 years down the line, right? Suppose I bought it in 2023 and I'm in 2025 right now. The cost of the car, if I were to sell it to somebody, right, I'm only going to get 3 lakh or 300,000. So in this particular case, what happened? My decrease will be your original price, right, minus your current price of the product. So it will be coming out to be 200,000. That's the loss you're making, right? That much you're going to lose when you're going to sell the car. Now, what is the percentage change? What is the percentage decrease in this particular case? It is the amount with which it has decreased, which is 200,000, divided by the original amount. In both the cases, remember, whenever you're calculating the percentage, right, it has to be calculated against the original amount, not against the new amount. Okay, so it will be 5 lakh or 500,000 into 100%. Again, the same concept, marks scored versus divided by total marks, right, into 100%. It's the same concept everywhere. Okay, so if you see, you cancel out all these zeros and this becomes 20. So your percentage decrease in 2 years is 40%. Got it? So this is how you calculate increase and decrease. So there is something called a multiplier also, which I can use instead of doing all these things. That will be a little bit, what do you say? Let's look at some examples. Okay, I'll start with some simple examples and then I'll go to some difficult ones to basically explain you that how this topic plays out. Okay, so here in this particular example, what are they saying? In a garden there are 2000 trees. Their total number of trees are 2000, out of which mango trees are 12% of that 2000, lemon trees are 18%, and the rest are orange trees, they are saying. So if you see the data which they have given you, right? So total trees, you need to put the details. Total trees is 2000, right? Mango trees is 12%, right? So now, if 12% of the total population is mango trees, you will be able to go ahead and calculate. So that will be what? If you want to calculate the number of mango trees, it will be 12 divided by 100 into 2000, right? These two zeros gets cancelled. So the total number of trees are 240. Let it be there. Now the next one, lemon trees. Lemon trees is equal to 18%, right? Which is nothing but 18 by 100 into 2000. Right, these two get cancelled. You have 360 lemon trees, and now they are saying that the rest are orange trees, right? How can I calculate orange trees? So orange trees will be, the total number of trees are 2000, right? minus your mango plus lemon trees. That is what it's going to be. So you can simply put the value over here. What did you get? 240 mango trees plus 360 lemon trees, which is equal to how much? 600. So 2000 minus 600 will give you 1400. Right? You got the answer? So if you look at it, these three should add up to 2000, as I told you, after you calculate everything. And similarly, there is one more way. I could have done it in one more way. The percentage of orange trees will be how much? It should always be 100 minus 12% plus 18%, right? So this should give how much? 100 minus 30. 100 minus 30 is 70%, right? Right? That is what that is the percentage of orange trees which are there in that particular garden. Now, if I use 70% and calculate 70 divided by 100 out of the 2000 trees which I have, look at it, I get the same answer, 1400. Do you get the same answer? That's how you solve the problems. Okay? Keep it very simple. Let's look at this example, right? This is a little bit, what do you say? There is a lot of data points which they have given over here, and they're asking us to calculate the percentage for all of these. So let's understand the problem first and put the points clearly so that we understand everything. They say the cricketer scored a total of 62 runs in 96 balls. So first note down the points what they have given. Runs scored, total runs scored is 62. In how many balls? Balls played is 96, right? That's what it is. Now they're giving us the breakdown of this 62 if you look at it. So number of sixes hit is 3 sixes. So can I go ahead and calculate the number? What's the total score he is making by hitting 3 sixes? It is 80, right? Similarly, fours, how many fours did he hit? He hit 8 fours. So 8 times 4 will give me 32, right? He made 2 twos basically. So 2 times 2 will give me 4, right? And he took 8 singles. 8 singles. So put it as 8 into 1, which is equal to 8. Now just check this if it is tallying with this one. 18 plus 32 is 50. 50 plus 12 is 62. Good. So it tallies exactly with the total number of runs scored. Now what did they ask us to find out? Look at the problem now. What percentage of the total runs came in sixes? What percentage? They are asking you to calculate the percent. How many runs did he score in sixes? 18. What is the total score? 62. So can I do this? 18 by 62 into 100. Right? That is one. Second one, they told what percentage came in fours. Total runs scored in fours is 32. 32 by 62 into 100. Right? Similarly, in twos and in singles. So total runs scored in twos is 4. 4 divided by 62 into 100. And this one will be 8 divided by 62 into 100. So what do you get over here? So this 2 9s are 231 over here, right? 31. So it will be 900 by 31 over here. Here it will be 1600. Yeah, this will be 1600 by 31, right? 2 16s are 2 31s are. Similarly, this will be 2 31, 2 4s are 31. So this will become 200 by 31. This is all percentage. Remember, this will be all percentage because you are already calculating the percentage by multiplying with 100 over here. Look at it, and this will become 400 by 31 percentage. So we can do the math and get it out. What's the percentage? So understood? This is how you calculate. Okay, one more example over here. Let's read the problem. A certain school has 300 students, right? Students. 142 of whom are boys. So note down the problem. Number of students is equal to 300, right? Number of boys is equal to 142. So therefore, what can you calculate? Number of girls will be equal to this minus this, which will come out to be 158. That's the total number of girls in the. So from the first statement, I can make out this data. Now I'll go to the second statement. It has 30 teachers, 12 of whom are men. Okay, so they are saying number of teachers is equal to 30. Number of male teachers is equal to 12. So therefore, number of female teachers will be equal to this minus this, which is 18, right? I have got my data sorted out, whatever they have given the problem. Now I'll go to the question. What percentage of total number of students and teachers are female? Right? They're asking us to calculate the percentage of females amongst students and teachers. So what's your total population? What's your total population? Like student plus teachers. This will be equal to 300 plus 30. There were 30 teachers. So your total population, including students and teachers, are 330. In this one, total female population, students plus teachers, we have calculated it out. Total number of girls were 158 plus total number of female teachers are 18. So how much do you get here? This becomes 172, right? Oh, sorry, 176. This is 176, right? So now you can easily calculate the percentage. So therefore, percentage of females, students plus teacher, will be equal to total number of female students, students plus teachers, out of the total population, which is 330 into 100%. That should be our answer. Right? Make sense? I hope you guys understood the concepts of percentage, right? This is a very simple chapter. So practice a lot of problems. After this video, I hope that your concepts are clear, right? And practice a lot of problems from your school exercise books. And if you have already completed that, right, go online and find out questions which are a little bit challenging. Try to challenge yourself. Then you'll be able to gain more confidence in a particular topic on that subject. Okay, so if you have liked the video, right, if you have loved seeing my content, right, I would request you to like the video, subscribe it and forward it to your friends. I want this content to go to as many students as possible so that they can sit at home and study, okay, by watching my videos.